Number 4, we got cosine of 2 theta, and we got cosine squared. And I'm not really sure what they want you to do exactly. It should show that they have period pi. Well, one way we could show it is just plug in the values, 0 to pi. So this is pi over 2, this is pi over 4, and this is 3 pi over 4. So if I look at cosine 2 theta first, I would have cosine of 2 times 0, which is cosine of 0. Can't think of the unit circle unless I see it. Okay, cosine of 0 is equal to 1. For this one, we have cosine of 2 times pi over 4, which is cosine of pi over 2, which is 0. This one we have cosine of 2 times pi over 2, which is cosine of pi, which is equal to -1. This one we got cosine of 2 times 3 pi over 4, which is cosine of 3 pi over 2, which is equal to, cosine 0. And cosine of 2 times pi is equal to cosine of 2 pi, which is equal to 1. Now I'm going to talk about how that's not good enough. But let's look at cosine squared. If I plug in 0, cosine squared of 0, that's cosine of 0 is 1, so that's 1 squared or 1. Cosine squared of pi over 4. Well, pi over 4 is right here, and that's square root of 2 over 2. So we got square root of 2 over 2 squared, which gives us 2/4 or 1/2. Cosine squared of pi over 2, and pi over 2 would be 0, so we got 0 squared or 0. And we got cosine squared of 3 pi over 4, which is right here, which would be negative square root of 2 over 2 squared, which gives us 2/4 or 1/2. And I got cosine squared of pi, and pi is -1, so we're going to have -1 squared or a +1. Now see, it starts at 0 and starts over. Now to truly say this is not a proof, we're showing it, but to truly show it, I think you'd have to go another to 2 pi and fill out everything in between. And then you can see a pattern. Now that's not proving it, but they're not asking you to prove it, they're just asking you to show it. And this might be enough just to show it.